Hello everyone, welcome to our YouTube channel. Today we are exploring the fundamental of algorithms, linear search and merge sort, whether it's finding an item in a list or organizing large amount of data efficiently. These techniques play a crucial role in computing. In this video, we will break down how these algorithms work, where to use them, and why they matter. Let's get started. My friend Ethan will explain the next slide.
Hello everyone, I will explain what is the linear search and how it works. Linear search is one of the simplest searching algorithms. It is a method used to find a specific element in a list or an array by checking each element one by one until the target is found or it reached the end of the list. And there are some advantages and disadvantages of linear search. The advantage of linear search is it's simple. It is one of the easiest searching algorithms to understand and implement. And the next one is it works on unsorted array. Unlike binary search, which require a sorted array, linear search can be used on any dataset. And the last one is it no extra memory required. It does not need additional storage space as it's search in place within the given array. And the disadvantages of linear search is it's slow for large dataset. Since it checks element one by one, it becomes inefficient when dealing with a large number of elements. And the next disadvantages is inefficient. The worst case scenario requires checking every element in the list, making it slower compared to other searching algorithms like binary search. And I will explain how linear search works using a simple example. Let's say we have an assorted array and we want to find the number 8. And we start from index 0, where the number is 3. Since 3 is not equal to 8, we move to the next element. And it will continue and check each index one by one until 8 is found in array. Finally, at index 4, we find 8. Since we found our target, we return the index 4 as the result. And this is how linear search works. And the next topic will be explained by Andy.
So the time complexity of linear search. The time complexity of linear search is O of n, meaning the search time grows linearly with the size of the input. In the worst case scenario here, the target element is either not present in the list or, in this case, is at the end of the list, requiring the algorithm to compare the target with every element in the list. So on the other hand, the best case scenario is when the element is found at the first position, resulting in the time complexity of linear search of O of 1. So I will continue explaining what merge sort is. Merge sort is a divide and conquer algorithm, which just means it breaks down into smaller, easier to handle parts, sorts them, and put everything back together in the right order. One big advantage of merge sort is stable sort. It keeps identical values in the same order, which is useful in certain applications. It also has predictable performance. Unlike quicksort, which can slow down in some cases, merge sort always runs in O of n time no matter what. And it is also great for large datasets, which is why it's often used in databases and large-scale applications. On the downside, merge sort uses extra storage because it needs to create temporary arrays while sorting. It can also be a bit slower for small arrays since the extra work of splitting and merging takes more time than just using a simple sorting method like insertion sort. And my friend Tentu-san will continue on with the presentation.
Okay, hello. For now, I will walk you through how merge sort works visually. Imagine we have a array size of 4. As my friends Andy explained, merging works like dividing arrays into smaller sub-arrays. So it divides to arrays, until it reaches the single self-arrays. Once it reaches the single self-arrays, it will compare the values. For that, we're gonna compare like threes and one. So one is smaller, so we're gonna be like one is gonna be the first one, three the second ones. For the next array part, 7 and 5, we're gonna compare 7 and 5 together. For that, 5 is smaller, so 5 gonna be the first one, 7 gonna be the less. So we got 1, 3, we got 5, 7. And the last part of mass sorts is gonna be like merging them into the single array. To be merged, we have to compare again which array has a smaller value. For that, first array has a smaller value, so it's gonna be the first place. And margin then, we're gonna be like sorted array. And then I'm gonna explain the time complexity of mass sort. For the mass sort, for both best case and worst case, it can take all of and log n. You're gonna be like confused. Why? Don't worry, I will explain. Imagine you have an array size. So you have like merging, dividing, then into this smaller sub-arrays. So it's gonna be take like log n. And then we have to merge them back into a single arrays. For that case, it's gonna be take like all of n time. So combining the divide and conquer process or log n and merging process log O of n together, we're gonna be like we will get O of n log n. So for both best case and worst case, gonna be like O of n log n. Of how the linear search and mass sort work in the real life. For that case, my friend Stanley will explain.
Okay, hello. I'm going to explain to you about the real life usage example of linear search and mass sort, especially in mainly two tags, which are for a specific book by title and sorting the books for better organization. Firstly, in the case of searching for a specific book by title, we're gonna use linear search. System sorts all book records alphabetically by title using merge sort to make future searches faster. This ensures that book listings remain structured for better user experience. Let me explain how it works together. If the book list is unsorted at the first of the week, the system uses linear search for quick lookups. But at the end of the week, all these books must be sorted periodically. The books, we're gonna use merge sort so that future searches can be optimized using binary search instead of linear search, because if the books are all sorted, we're gonna have to use binary search instead of linear search because it is much more efficient. For those cases, we're gonna explain binary search. We will have to explain binary search in the future videos. So this is all about our explanation of linear search and merge sort, the combined usage in real life example of a case scenario. If you have any questions relating to the topics we presented, let us know in the comment box down below. Thank you for your attention and thank you for watching. Don't forget to subscribe.
Thank you.
Thank you.
Thank you.